A 45-minute meeting is crashing and burning. Four highly skilled professionals stare at a slow dashboard, talking over each other, getting absolutely nowhere. The support lead argues they need to focus on what customers are complaining about, a confusing layout. The database engineer brings up server logs, pointing to a query bottleneck in the backend. The product manager ignores them both, actively sketching a total redesign on the whiteboard. Meanwhile, the software engineer is already at their laptop, pushing code adjustments directly to production. The hour ends and zero decisions are made. Everyone leaves the room with a longer to-do list, and none of that work actually connects. All four individuals were doing useful work, but they failed to make progress because they lacked a shared map to locate where each person's thinking was currently sitting. We start with a horizontal line. The left side is the problem space, the right is the solution space. Next, a vertical axis. The bottom is the concrete, tangible reality. The top is the conceptual, the world of ideas. This diagram shows the map, dividing problem solving into 4 quadrants, starting bottom left, clockwise: problem definition, problem analysis, solution design, and solution implementation. By crossing these axes, an abstract workflow gains spatial reality. Every task now belongs to a specific location. We begin in Quadrant 1, the concrete problem space, known as problem definition. This is where you turn a vague, noisy complaint, like customer satisfaction is low, into a precise, measurable contract of what is actually wrong, before anyone writes a single line of code. The trap here is the XY problem. This happens when a stakeholder hands you their preferred fix disguised as a problem. If someone says, "We need a faster car," and you don't define the actual gap, getting to work on time, you might spend a fortune on engine tuning when a simple route change would have solved it. Once the problem is strictly defined, you move up to Quadrant 2, problem analysis. You leave the concrete reality behind and enter the conceptual space. You shift from observing what is wrong to hypothesizing and testing why it is happening until you isolate a root cause. The danger here is treating an untested hypothesis as a confirmed diagnosis. Think of a doctor who hears a patient complain of stomach pain and immediately prescribes acid reflux medication on a hunch without physically testing for gallstones. They guessed instead of diagnosing. The entire left side of the map serves a single purpose. It forces you to filter messy symptoms down into one validated root cause that is actually worth solving. With the root cause identified, you cross over to the right side into Quadrant 3, solution design. You generate several genuinely different options and filter them hard against the budget, timeline, and constraints you established back in Quadrant 1. A common failure here is the compromise trap. Imagine trying to dodge a ravine in a car. The driver wants to steer left, the passenger wants to steer right. The compromise is to go straight into the ravine. Teams often blend technically incompatible solutions just to keep office politics peaceful, resulting in a fractured plan that fails the original success criteria. Finally, you drop down into Quadrant 4, solution implementation. This is the concrete solution space, where your paper design meets reality. The work is executed, and the final results are rigorously verified against the original problem. The risk in this final step is translation loss. The physical tasks get executed exactly as written, but the logic and intent behind the design never make it to the implementers. An installer mounts solar panels on the wrong side of the roof because they were never told about the specific carbon target driving the design. When a team bypasses the first 3 quadrants and jumps directly into Quadrant 4, they achieve something highly counterproductive: the expensive, flawless execution of the wrong plan. Let's take that chaotic dashboard meeting from earlier and plot it on the map. The support lead, pinning down customer layouts, was in Q1. The database engineer, tracing the bottleneck, was in Q2. The product manager, sketching a redesign, was in Q3. And the software engineer, shipping code, was in Q4. Their work didn't connect because they were operating in 4 different stages simultaneously. They had never agreed on Quadrant 1 together. The map also acts as a diagnostic safety net. If your execution stalls in Q4, you don't just push harder. You use the framework to trace backward to see if you have a flawed design in Q3 or a misidentified root cause in Q2. Introducing a shared map turns a vague personal clash of opinions into a highly specific, located choice between options. When everyone can finally see where the work is happening, you stop fighting each other and you start fighting the problem.